Okay, let's work this example. Okay, we have in this circuit 2 resistors and 2 batteries. First question that I would like you to think about. Are R1 and R2 in series or in parallel or neither? Okay, so to make that check, we need to see if every loop that we can select in the circuit is going to include both resistors. That's an easy thing in this case because we have only one loop. And it includes both of them. So they are in series. It does not matter where they are in the circuit, they are in series. Okay, let me erase that loop. Okay. Now, I'm going to apply Kirchhoff's voltage rule to try to solve this problem. We have one loop, so one current. So my current, I can choose the direction. Again, like we talked about before, the direction is arbitrary. I'm going to choose it this way, I1. Now, other things I would like to point out in here, it's not needed really for solving the problem, but I would like to point it out using colors. Now, from here to here, we have the same voltage. From here to here, we have the same voltage. From here to here, we have the same voltage. And let's choose another color. Let's go purple. From here to here, we have the same voltage. Okay. Now, the next thing is, I'm going to apply the rules. So we chose arbitrarily the direction of the current. I labeled it I1. We don't need an I1 since we have a unique current. Let's call it just I. Let's go back to black pen. Okay. Now the next thing that we learned that we need to do, it seems I erased my yellow mark in there. I didn't see I did it, but let's mark it there. It's not really necessary, but I want it here. Okay, and we got to black. The next step we said that we need to do is write down or label pluses and minuses for each element in the circuit. We have 4 elements, so a minus for this one and a plus here. The current is going this way, so this is a plus for R1 and this is a minus. E2, this is the minus and this is the plus. And follow on the same direction of the current, so if I is going towards the right on top, it's going towards the left in the bottom. So here I have my plus and here is my minus. The next step is to write the voltage drop across each of the elements. So I'm going to write it in red. For R1, it's going to be R1I. For R2, it's going to be R2I. It's the same current through them, so I use the same current. Okay. Then my next step is to select a loop. I'm going to select a loop, choose a point in the circuit. I'm going to choose this. And then going around clockwise or counterclockwise, I'm going to go clockwise. Okay, starting there. Now the first element we meet is E1. Let me do it with another color so we see what we are doing. So the first element we meet is E1. So we have, and we meet the negative lead, so it's going to be plus E1. And then we go here and we meet the positive lead of R1, the positive end of R1, not lead. So it's minus R1I, since I'm going from high to low. And then going around here, continuing around, and I meet the plus of E2, so it's going to be a drop in electrical potential, so minus E2. And then we go here and we go from plus to minus for the resistance, so it's minus R2I. And we are back where we started, so this is equal to 0. So this is my equation. I can plug in all of my knowns right now. So E1, it's plus 50 volts. And then I have minus R1I minus E2, which is minus 10 volts. And then minus R2I is equal to 0. Now next step, I'm going to write the resistances. Plus 50 minus 10, that's plus 40 volts. Minus R1 is 5 ohms I. Minus R2, 15 ohms I is equal to 0. So solving for I. So I have plus 40 volts is equal to 5 ohms plus 15 ohms I moved it to the other side, and I is equal to 40 volts over 5 plus 15 over 20 ohms. So that's going to be 2 amps. That's my answer.